Okay, so here we have question E. It says that we have a 20-kilogram ladder leaning against the frictionless wall and resting on a frictionless horizontal surface. To keep the ladder from slipping, we have the bottom of the ladder tied to the wall with a wire. The tension in the wire is 29.4 newtons, and the maximum tension before the wire breaks is 200 newtons. Here in part A, it says that we have an 80-kilogram person climbing up halfway up the ladder, and it's asking us to find the force that will be exerted by the ladder against the wall. So I have my setup here for the free body diagram. I have the FW, this is the force of the wall on the ladder, Fn here at the bottom, and then I have at the center of the ladder I have the FGL plus Fg of the person, and the tension in the wire is going to the right, preventing the ladder from slipping. So all the given information is right here. We have the mass of the ladder, mass of the person, tension in the wire, maximum tension in the wire. The height is 5 meters. The length is 5.22. This is I use the given information here, the 5 meters and the 1.5 meters to find the length of the ladder, which is the 5.22 meters. And then we are trying to find, in part A, we're trying to find FW, which is F of the wall on the ladder, which is equivalent to F of the ladder on the wall. And we can also call it TW, which is the tension in the wire, because it's equivalent. It's holding the ladder from slipping, so it's equivalent to the tension, the force of the ladder on the wall. So I have my setup for the equations. In the x direction, I have my FW equals TW, and then I have my Fn equals FGL, Fg of the ladder plus Fg of the person. My torque equation is Fg of the ladder plus Fg of the person. All of them are multiplied by L, which is my 5.22 meters divided by 2 times cos theta. And oh yeah, by the way, so I found theta up top here, given the using the information given, which is the 5 meters and the 1.5. I used the tan inverse of 5 meters over 1.5 meters, and that gave me the 73.3 degrees. This is my theta, and this is equal to TW times H. For part A, we're trying to find TW, so I'm going to isolate for TW. So TW is equals to TW equals to FGL plus FGP, all multiplied by L over 2 times cos theta, and divided by my height. We can plug the values in. So 20 kilograms plus 80 kilograms of the person. All of this is multiplied by 9.81 meters per second squared. And that is multiplied by 5.22 meters divided by 2 times cos 73.3 degrees. Oh, and we also use the 5.22 meters here. That's because here in the question it says how far from the bottom end of the ladder can an 80-kilogram person climb? That's part B. But also because we're trying to find the mass of the force that the ladder is exerting on the wall. So in this case, we are taking the length of the ladder as our reference here. So that's why we're using the 5.22 meters. And then we divide that by our height, which is 5.0 meters. So TW equals to, we can calculate the value. So we have 100 kilograms times 9.81 meters per second squared. This is multiplied by, have to divide 5.22 divided by 2. So that's 2.61 meters times cos 73.3 degrees. And this is 0.2874, all divided by 5.0 meters. If we plug all of these values in our calculator. So 100 times 9.81 times 2.61 times 0. Divided by 5. So this gives me 147.15 newtons. So this is our FW, which equals to TW. And this is what we're looking for in part A. So if you check our answer here, yeah, it's correct. Perfect. So in part B, it's asking us how far from the bottom end of the ladder can an 80 kilogram person climb. So this is the part that I was explaining earlier. So it's asking us about this length. We're not taking this length as our reference. No, just this. So this is what we're using in our torque equation. So in order to find the maximum, the D maximum here, we have to use the torque equation again, but we have to tweak a little bit. So what I'm going to do here, so this is for part B, I'm going to have my setup like this. So FG of the ladder times L over 2 times cos theta plus FG of the person times D max, that's what we're trying to find, times cos theta is equal to maximum tension in the wire times our height. And we are trying to find our D max here, so we're isolating for that. So it's going to look like this. T max times height minus FGL times L over 2 cos theta divided by FG of the person times cos theta. This is going to give me my D max. I can then plug in my values. So T max is 200 newtons times 5.0 meters minus FG of the ladder, which is 20.0 kilograms times 9.81 meters per second squared times 5.22 meters divided by 2 times cos 73.3 degrees, and all of this is divided by FG of the person, which is 80.0 kilograms times 9.81 meters per second squared times cos 73.3 degrees. So then you have to find our values here. So 200 times 5 is 1,000. So 1,000 newtons times meters minus, you put all of this in our calculator, so 20 times 9.81 is 5.22 divided by 2 times cos 73.3 degrees, and this gives me 147.15 newtons. And then we divide that by 80 times 9.81 times cos 73.3, and this is my 225.52 newtons. And then we plug all of this in the calculator, so 1,000 minus 147.15 divided by 225.52, and that gives me 3.78 meters. So this is the D max, the maximum distance that the person can climb up the ladder before the wire breaks. So we go up and check the answer. Yep, 3.79. And that's close enough. Perfect. So now we have the question completed. Thank you for listening.